Welcome back. In this video, we're going to discuss one of the most powerful applications of discrete choice models, and that is measuring consumer surplus for policy analysis. This is where discrete choice models really shine in empirical work. We can take our estimated models and then convert their parameters into dollar terms, which can then tell us about consumer welfare of different policies. Common examples include measuring the benefits of school vouchers or measuring the harms of environmental degradation. Consumer surplus is a fundamental concept in economics. In your introductory economics classes, you might have measured consumer surplus as the difference between a consumer's willingness to pay and what they actually paid. And in this video, we'll talk about how we can use the multinomial logit model to infer consumer surplus using the estimated preference parameters. And to start with, we need to understand the concept of expected utility. Now, obviously, willingness to pay relates to individual level utility at some granularity. But to keep things policy relevant, we as data analysts need to recognize that we only see the observable component of utility and not the unobservable. So because of this, we need to quantify consumer surplus in terms of expected utility rather than actual utility. And another trick is that we can't just take an expectation over utility, because we know that consumers are utility maximizers. So we need to actually take an expectation over the maximum of the options that the consumer is deriving utility from. This will give us a slightly different calculation than a simple expected value that we'll talk about now. So the concept of expected utility is that utility is composed of little u and epsilon, and we as the data analysts don't see epsilon. So if we want to compute the expected utility to the individual, we need to take the expectation over the maximum of the little u plus epsilon across all of the alternatives. The expected value is being taken with respect to epsilon. That's what's unobservable to us. And we won't go through the derivation, but it's somewhat similar to the derivation of the logit choice probabilities that we covered in a previous video. But basically, for a multinomial logit, this has a closed form formula, which is the log of the sum of the exponentiated u's, summed across all of the j alternatives, plus a constant, which is called Euler's constant, which is approximately 0.577. Now, it can also be helpful to think about an alternative expression for expected utility. So we can take that log sum formula that we already looked at on the previous slide, and we can just multiply and divide by a constant, which is exp of uij. Actually, this isn't a constant necessarily because the betas are embedded in it, but we can just multiply and divide by a number, and then that will allow us, with some algebraic manipulation, to pull this exp of uij out of the log and just have it be uij. And then we have, by properties of exponentials, the exponentiated difference in utilities between uij and ui capital J. And then if we're imposing a normalization, just bring that, have the summation going from j equal 1 to cap j minus 1 and deal with it this way. So all of these are equivalent depending on which normalization we're making. And the reason that I'm bringing it up right now is because we can think about, in a dynamic model, a person may not know what their future epsilon is going to be. So they're going to have to take expectations with respect to their future epsilon. And so we'll get to a similar representation of this in a later video when we talk about dynamic discrete choice models. So this is just kind of planting the seed right now. But just for the purposes of this video, just know that the log of the sum of the exp of the u is the formula for expected utility. So then, how do we get from expected utility to consumer surplus? Well, in our model, we need some kind of monetary variable to tell us the conversion rate between utils and money. In most cases, we'll have either a price variable or a income variable, and we're going to take that coefficient in front of the price. That's going to allow us to convert the expected utility into a monetary value, which is what consumer surplus should be. And so from the expected utility, we just get the expected consumer surplus as 1 over delta, where delta is the coefficient on price, times the expected utility. So if we apply the logit assumption, then we're going to get this formula for the expected consumer surplus. So then how do we compute the change in expected consumer surplus from two different policies, maybe a status quo policy and some counterfactual that we're thinking about evaluating? Well, basically, we can just compute this expected consumer surplus before and after the change, and that's going to give us the change in expected consumer surplus, which can be informative of whether the policy that we're analyzing is welfare enhancing. So if the change in expected consumer surplus as a result of the new policy is positive, then we know that the policy is welfare enhancing. And a critical thing here that we'll talk about in a future video is that we're assuming that everybody has the same price sensitivity. We could subscript this delta with I if we wanted to, and we'll talk about that in a future video. So this constant C canceled out when we do this difference in the two different regimes of consumer surplus. And we should also note that the superscripts in the summation index, those can be different values, meaning that we might introduce a new mode of transportation, or we might introduce some other new choice alternative. So this is really a foundational tool for any kind of cost-benefit analysis using an actual empirical discrete choice model. And as a compelling example, let's think back to a paper that I covered in a previous video that was measuring the impact of school vouchers in India. I'll put that paper up on the screen right now. So this was the paper analyzing an experiment where some villages got the option to use a private school voucher to send their children to private school. And then they were computing how valuable that option is to choose private school is to households compared to how much it costs the government. And they basically found that this targeted voucher program has a marginal value of public funds of at least 3. So this just means that the beneficiaries of the voucher value that at 3 times what it costs the government to pay for it. And they also find, if you read the paper, particularly section 5 of the paper, they'll talk about the fact that under some situations, this voucher program could be self-financing because of the surplus that it generates for the households. So just to wrap up, the main idea is that even if we don't see each consumer's epsilon, we can still take expectations across all the consumers that we're analyzing and use that to estimate what the welfare gain or loss might be to a potential policy that we might want to implement. The next video will conclude this mini-series on static discrete choice models and the logit model. We're going to talk about how we measure goodness of fit in logit models, as well as walking through a canonical paper that was an early adopter of these tools from nearly 50 years ago.